Okay, so I'm going to show you our most advanced event marking device, which is a black box mBBTK V2. So basically the goal of this piece of hardware is to event mark in things like EEG, eye tracking or neurophysiology studies in short. It's got lots of TTL event marking capabilities both in and out, as well as a range of other sensors. So what I'll do is I'll show you the sensors that are available and then how they might work with the event marks. The whole goal of this device is to event mark in real time, but also record everything that happens on its own independent timer, which is completely independent of the PC that you run it on, as it's got its own RAM, and once it's told what to do, it'll go away and do it and record all the timing data and everything that happened on its own RAM and then upload it when it's finished, in short. So basically you've got 4 opto-detectors that can be used for detecting visual stimuli on screen. You've got 2 microphones for detecting any audio events, and you've got audio in and out, so they're pass-through, so you can pass through your speaker into there and then out to the actual speaker. You've got 2 response pad or TTL inputs on the front, so you've got 8 TTL front inputs, so that could be from your own device or from one of our response pads, or something like the USB TTL module, or say a pressure sensitive response pad or something else, or there's a standard black box toolkit response pad input as well. So the LEDs on the front basically cover the optos, the mics, the audio pass-throughs, the response pad on the front, the TTL front input port, the rear input port, when it's event marking on the rear, which I'll show you in a sec, and then there's a kind of a heartbeat monitor on there as well. You've got an LCD screen for showing you what happens on the front, so that's the firmware version, copyright, what's been programmed, etc. And you've got a rotary encoder which will let you set the thresholds and sensitivity on any of these. So on the rear you've got 24 TTL inputs, so that's 24 different channels or lines from your own devices, and then you've got 24 TTL event mark outs, so that's for event marking on EEG, eye trackers or any other device that supports a digital in. So that's 48 digital I/O ports or channels or lines, however you want to phrase it. You've got an update port for updating the firmware. You've got a standard USB port which you connect to your PC with, an on-off switch, and a 9-volt power supply which will be specific to your region. So what we'll do, we'll plug all this together and run it up with our software app, and then we'll do a little cross-modal study with some event marking, show you how easy it is to use. So I'll just plug the power supply in there, and then what I'll do is I'll plug a microphone in, so we can put that next to one of our microphones. So we'll put that there. What we can do then is we'll use the opto on this second PC screen and put it into opto 1. So that's going to look for a visual stimulus. Just slide that back a bit. So we're looking for some audio on the microphone here, and then we're going to look for some a visual stimulus there, and we're going to event mark those separately on two separate channels. We'll just plug the USB port in there. We'll plug that into there. Normally what you'd do as well is you'd have 2 25-way leads plugged into this breakout board, or you could do that. Basically these 48 screw terminals that let you wire your own devices, or you can just plug your own cable straight into the back of the mBBTK. Depends how you want to do it. generally you'd wire these as a test, or you'd have us build custom cables that plug straight in the bike, or you'd build your own after you'd done the testing with this breakout board. But for now we'll pop that on one side. So we'll switch the unit on. And just wait for that to come up, and then what we'll do is we'll start our software app. So what you can do, you can adjust the sensitivity on here using the rotary encoder and the push button, but what we'll do, we'll just load the defaults for now. Okay, so what we're going to do, we're going to build up what to event mark and when. So it'll basically event mark in real time, and it'll record everything that happens into its own RAM, and it'll timestamp everything that happens in the real world, like the opto, the mic, or whatever it is, buttons on a response pad going down, any other input that's going in. It'll event mark those with sub-millisecond accuracy, store them in its own RAM, and then upload it afterwards. So what we'll do, we'll have a look at the event marking. So this is how you pair inputs and outputs. So in other words, how you pair the visual stimulus image opto-detector to a TTL out that goes into your EEG digital import, or your eye tracker digital import. So basically what we do is we look for a trigger, and we can say, okay, the trigger's opto 1, and we're going to event mark it on rear out rear out 1. So that's on the 25 way on the out port. Now we can say, okay, if I hear something on microphone 1, we'll event mark on TTL out 2. So you can see we're gradually building up a visual representation of what the inputs are. So what inputs we get in the real world and what we map them out to as an event mark. Yep, so we've got the triggers and the event marks, and they're basically 5-volt signals that are high whilst we get the input we're looking for. And we can run that for, we'll just run that for 30 seconds in this example. What we do before we start as well, we clear the Blackbox Toolkit RAM, which is internal. After you've formatted it for the first time, it's a lot quicker on subsequent times. The other thing you can do as well, you can download any of these event marking profiles to the box, and you can run it off the PC. So you don't have to be linked to the PC to run the profiles. At the moment, I'm going to program the black box. It's all gone across into here. So once we say going, it'll run independently and do the event marks. But you can have up to 10 of these profiles loaded into the black box, and then when you power it on independent of the PC, you can choose one of the 10 profiles by selecting it with a rotary encoder, pushing the button in, and then it'll just run forever. So it'll basically say, okay, every time I see an opto, I'm going to event mark that for the duration of the opto, the stimulus image, or every time I detect something on the microphone, I'm going to event mark that for the duration of the audio, and it'll just go away and do that forever. So that's a really neat way of running it off a PC, where you don't need to look at the data or look at the timing data. You just want exact event marks at all times. So what I'll do is I'll start the cross-modal study at 500, pinging backwards and forwards, and you should be able to see the LEDs illuminating on there as things are being detected. So what I'll do is I'll set that going, and you'll see the event marks that we programmed in appear down there. So hopefully you can see the red LED illuminating with the event mark, and you can see the time that it's running for in the progress bar. So you can imagine if you had a response pad, you'd be event marking the response buttons going down as well. So when it finishes, it gives you some statistics about the capture. So I'll just turn the cross-modal bit off. So that's just uploading all that data now. Right, so we click on done, and then what it'll do, it'll plot everything that happened down there, so we can see the opto, and basically we can then go through and we can compare any event to any other events. It's basically a very similar bit of software as to the normal black box V3 software, but this is geared towards event marking, although it does record all the timings, but it doesn't let you generate anything as though you would a real human. So it won't let you wait, say, 300 milliseconds and then do a response with a key down or a plunger down on the robotic key actuator. Yeah, so it's a slightly different product. It's aimed at event marking in EEG, FNIRS, eye tracking, or anything where you need accurate event marks that are going to stand the test of time and just keep going forever, in short, if you use an onboard profile. But you can also check the timing on this as well.